So now we are going to discuss this topic, which is called as maturity concept. Okay. So up till now, whatever we have discussed, we have just discussed time aspect. Okay. That 28 days, that is the characteristic strength after 28 days, that is important for the strength development. But it is not only time. The temperature during this curing period is also very important, and that will also influence the gain of strength of concrete. So this strength development of concrete depends on both time as well as temperature, and you can say that it is the strength aspect of concrete. It is the function of summation of product of time and temperature. So this summation, it is called as maturity of concrete. So if just in the form of equation, if you want to put that aspect, it is called as maturity, and maturity is nothing but summation of time into temperature. So this temperature is calculated from an origin lying between -28 to -10 degree. Why this temperature that we are selecting as a datum कि -12 से -10 के डिग्री के बीच हम उसको एज ए स्टैंडर्ड ले सकते हैं. वाई? बिकॉज एक्सपेरिमेंटली इट इज फाउंड दैट हाइड्रेशन ऑफ कॉन्क्रीट कंटिन्यूज टू टेक प्लेस अप टू -11 डिग्री. -11 डिग्री तक भी टेम्परेचर जाता है तो हाइड्रेशन हो सकता है. बेसिकली दिस हाइड्रेशन इज रिस्पॉन्सिबल फॉर द गेन ऑफ स्ट्रेंथ ऑफ कॉन्क्रीट. दैट्स वाई दिस -11 डिग्री इज जनरली सिलेक्टेड एज द डेटम लाइन फॉर computing maturity of concrete. Okay, so here as it is the summation of time and temperature, its unit would be degree centigrade hours. So this degree centigrade indicates its temperature, and hours that is related to time, or you can measure it in degree centigrade days. So this is the unit of maturity of concrete. Now which sample that can be considered as a fully matured concrete? अगर कोई fully matured concrete है तो उसमें कितना वैल्यू होना चाहिए of this maturity? So basically any sample of concrete which is cured at 18 degree centigrade, okay, which is cured at 18 degree centigrade for 28 days, it is taken as fully matured concrete. So you should know that the fully matured concrete होता क्या है. कोई भी concrete जिसको हमने 18 डिग्री टेम्परेचर पे क्योर करने के लिए रखा है 28 डेज के लिए, and after that whatever its maturity is there, it would be equivalent to how many days? 28 days. So 28 days, convert it into hours, so multiply by 24. So 28 into 24 multiply by, as our temperature is 18 degree, from that you have to deduct your datum line temperature, and that is -11 degree. So 18 minus -11, so this maturity 19488 degree centigrade hour, this is considered to be the maturity of fully cured concrete for the standard calculation. Now exact value would be this, but generally for the standard calculation we are considering that fully cured concrete, it has maturity of 19800 degree centigrade hour. Why it is different? Because exactly -11 degree नहीं लेके रखा है. So you can say that for the fully matured concrete, the maturity would be 19800 degree centigrade hour. So that is maturity of fully cured concrete standard way. So if it's not possible कि 28 days तक आप same temperature maintain कर पाएं, ठीक है? So if the period is broken into smaller intervals, and if the corresponding temperature is recorded for various interval of time, so you have to make the summation of that product of time and temperature. Okay, कि भाई 8 दिन के लिए इतना टेम्परेचर, 10 दिन के लिए इतना टेम्परेचर, so that way also you can calculate the maturity. So basically it's the summation of product of time and temperature, so that will give you the accurate picture of the maturity of concrete. So this maturity concept is very useful for estimating the strength of concrete at other maturity. अलग maturity आपका आता है as a percentage of strength of concrete of known maturity. If you are having data of the known maturity, concrete का जो known maturity है, so you can get the strength of concrete at other maturity as a percentage. So I will just give you one small example for that, so that aspect will become more clear to you. So here this, if we know the strength of concrete at full maturity, जो तो आपका standard value है, so we can calculate the percentage strength of आइडेंटिकल कॉन्क्रीट. एक कॉन्क्रीट जिसका हमको पता है कि फुल्ली मैच्योरिटी पे इतना आ रहा है, ठीक है? सो आइडेंटिकल कॉन्क्रीट का हम स्ट्रेंथ एट अर्ली डेज वी कैन फाइंड आउट एज ए परसेंटेज ऑफ दैट कॉन्क्रीट ऑफ नोन मैच्योरिटी. So here this graph, it represents compressive strength versus maturity. So you can see that if maturity is increasing, so this is log scale of maturity, then compressive strength is also increasing. So basically this temperature and time, both aspect when we are considering, it will become a maturity aspect. And it is when we are plotting against strength, then it will give a straight line. So now, if you want to find out the strength at any maturity as a percentage of strength of maturity of fully cured concrete, तो fully cured concrete का value तो same है 19800 degree centigrade. But if you want to find out the strength at any maturity as a percentage of strength of at that particular maturity, this equation can be used. A plus B log 10 मैच्योरिटी डिवाइडेड बाय 10⁻3, मतलब 7 दिन के बाद कितनी मैच्योरिटी, 8 दिन के बाद कितनी मैच्योरिटी है, ठीक है. सो दिस मैच्योरिटी यू हैव टू पुट हियर एक्चुअल मैच्योरिटी एट पर्टिकुलर डेज, इट विल गिव यू द परसेंटेज. ओके, सो हियर दिस वैल्यू ऑफ कोएफिशिएंट इन ए एंड बी, इट डिपेंड्स ऑन द स्ट्रेंथ लेवल ऑफ कंक्रीट. कौन से स्ट्रेंथ का आपने कंक्रीट लिया है, अकॉर्डिंगली दिस ए एंड बी आर वेरी. सो दिस कोएफिशिएंट्स आर गिवन बाय प्लॉमैन, and these are the coefficients which can be used for the maturity equation. So here it is given that strength after 28 days at 18 degrees centigrade, so that is maturity, that is a fully cured concrete, is 19800 degree centigrade. तो coefficients दिए हैं A and B. These are for different strength range. So if your strength range is less than 17.5, 17.5 to 35, 35 to 52.5, 52.5 to 70, then these values of coefficients that you have to consider. Now, to understand whatever I explained up till now, I will give you one small example that you can solve in your notebook. Okay, so this example will explain you the concept of maturity, how it is useful. Okay, so just try to see this example. It's a very simple example, but that will clear your mind regarding this maturity aspect. So here the example says that the strength of a sample of fully matured concrete, मतलब एक fully matured concrete है, उसका strength आपको पता चल रहा है, that is 40 megapascal. So strength of sample of fully matured concrete is found to be 40 MPa. We know that this is the fully matured concrete and its strength is 40 megapascal. Now we have to find the strength of identical concrete, मतलब उसके जैसा ही concrete है at age of 7 days, कि भाई उसके जैसा ही एक concrete आपके पास है, identical concrete है. So if you want to find out the strength of that identical concrete at the age of 7 days when cured at an average temperature. Now here you can see there are two different temperature. During night time temperature is different, during daytime temperature is different. So when cured at an average temperature, during daytime 20 degrees centigrade and night time it is 10 degrees centigrade. So you have to first understand the example, what data are given and what you have to find. So data given is that कि fully mature concrete है, उसका strength 40 MPa है. You have to find out the strength of identical concrete. हमको 7 दिन के बाद उसी के जैसा concrete का strength कितना होगा वो हमको जानना है. So that will give you in percentage. Okay, and its curing temperature are given for 7 days. So here we have to first find out maturity of concrete at age of 7 days. कि ये जो कंक्रीट हमारे पास है जिसको हम क्योर कर रहे हैं, 7 दिन का डेटा हमारे पास है. सो फॉर 7 days. नाउ if you want to convert it into hour, you have to multiply by 24, but it cannot be multiplied by 24. Why? Because for 12 hours temperature is different, another 12 hours temperature is different, daytime temperature is different, nighttime temperature is different. So here we are considering this 7 days, convert it into hours. So only for 12 hours it is 20 degree, because it is 20 degrees. So 20 minus 11 plus next duration, that is our night time, that is temperature is 10 degree. So 7 days multiply by 12 hours, because 12 घंटे तक 10 डिग्री पे हो रहा है, 12 घंटे तक 20 डिग्री पे हो रहा है. तो 7 into 12 multiply by 10, that is night time temperature, minus 11. So this minus 11, that is our determinant temperature up to which the hydration may take place. So if you make the summation of both during daytime, night time, you can get the maturity of concrete at age of 7 days. So by calculating, we can get it as 4368 degree centigrade hour. Okay, so understood up till now? It is maturity of concrete at age of 7 days. Now the strength range of this concrete fall in zone 3. Why? Because its strength is 40 MPa. So we have to find out this A and B. So here 40 MPa, it is coming in this zone 35 to 52.5. So its value is 32 and value of B is 54 because 40 MPa है fully mature concrete का. ठीक है? So A value is 32 and B value is 54. So now this equation, the percentage strength of concrete at maturity, अगर इसकी maturity 7 दिन के बाद 436 डिग्री है तो इतना percentage हुआ आपका 40 के comparison में. So A value put it as 32, B value as 54 and log of 10 here in this equation it is maturity divided by 10 raised to 3. So here maturity is 4368 divided by 1000 and if you will solve this then you will come to know that this value is 66.5. मतलब क्या है परसेंटेज है कि भाई ये 7 दिन के बाद उसका स्ट्रेंथ 66.5% ऑफ 40 MP होगा. तो 66 का अगर 40 मेगापास्कल का 66.5% of strength is gained by this identical concrete. So you can find out that strength of concrete in early days after 7 days. So similarly, this maturity concept may be very useful to find out the percentage of strength of identical concrete as compared to fully matured concrete. So that is the use, and this maturity it tells the importance of temperature during curing period. Now up till now we have discussed gel to space ratio, water cement ratio, then time aspect and this temperature aspect. But apart from that, this aggregate, they are also a very important aspect as far as the strength is not that much important but important. So we should know the effect of maximum size of aggregate on strength aspect. So earlier at one time it was thought that यूज ऑफ लार्ज साइज एग्रीगेट लीड्स टू हायर स्ट्रेंथ. पहले ऐसे माना जाता था कि अगर लार्ज साइज की एग्रीगेट है तो स्ट्रेंथ हायर होगी. व्हाट वाज द रीजन बिहाइंड दैट? दे कंसीडर दैट लार्जर द एग्रीगेट लोअर इज द टोटल सरफेस एरिया. जितना लार्ज एग्रीगेट होगा उसका टोटल सरफेस एरिया कम होगा. देयरफॉर द लोअर इज द रिक्वायरमेंट ऑफ वाटर और गिवन वर्केबिलिटी. लोअर सरफेस एरिया है तो आपका वाटर रिक्वायरमेंट कम है एंड वाटर रिक्वायरमेंट कम है फॉर ए गिवन वर्केबिलिटी. सो इनडायरेक्टली यू कैन से दैट it's a lower water cement ratio. So for this reason a lower water cement ratio can be used and which results in higher strength. So that was the notion that was earlier thought for. Okay, but however later based on the some investigation and some experiments which are done, it was found that use of large size aggregate did not contribute to higher strength. अगर आप ज़्यादा एग्रीगेट का साइज यूज करोगे तो वो कोई स्ट्रेंथ कंट्रीब्यूट ज़्यादा नहीं करता है as it was earlier expected from the theoretical consideration. But what was the reason? The reason is larger maximum size of aggregate gives lower surface area for development of gel. अगर उसका surface area कम है तो gel formation में जो बनेगा आपका development of gel bond वो भी कम बनेगा and that would be responsible for lower strength of the concrete because low surface area means development of gel bond that will be less. This less surface area will be available for the gel formation, and as you know that gel formation, that a CSH gel, that is basically responsible for the gain of strength. So that is why this will result in lower strength of concrete, not the higher strength. Okay, so maximum size of aggregate बहुत ज़्यादा है, so that will not increase the strength but it will decrease the strength. And secondly, the bigger size aggregate cause a more heterogeneity. बहुत ज़्यादा heterogeneity आ जाती है, homogeneity मिल जाती है, बहुत ज़्यादा heterogeneous structure हो जाता है concrete का, and which will also prevent the uniform distribution of load when stress. हम जब load apply करते हैं तो उसका uniform distribution भी नहीं होता. Okay, when it is being stressed. So when large size aggregate is used due to internal bleeding is also possible in the transition zone, and that transition zone will become more and more weaker. So transition zone is that zone in which there is a combination of cement paste and your aggregate, and this is due to development of microcracks, and microcracks are developed which result in lowering the compressive strength. And generally this high strength concrete or rich concrete means the cement proportion is higher as compared to aggregate. It will be adversely affected by the use of large size aggregate. So it is observed that कि high strength जो concrete होता है और जिसमें rich mix होता है concrete का, वो ज़्यादा अफेक्ट हो जाते हैं by the use of large aggregate. But lean mix और weaker concrete जिसकी स्ट्रेंथ कम है, जिसमें सीमेंट का प्रोपोर्शन कम है, it has less influence as compared to this rich mix or high strength concrete. Okay, so in lean mixes the larger size aggregate basically gives highest strength. मतलब अगर लीन मिक्स यूज कर रहे हैं तो आप हायर साइज ऑफ एग्रीगेट के लिए जा सकते हैं, बट रिच मिक्स या हायर स्ट्रेंथ पे जा रहा है तो आपको स्मॉल साइज के एग्रीगेट यूज करने चाहिए. ओके, सो इन रिच मिक्सेस it is the smaller aggregate which yields the higher strength. So here it is proved by these investigators by doing some experimental analysis. So here this graph shows the compressive strength versus maximum size of aggregate. So you can see this here, this cement content kg per meter cube दिया है, here 390, here in between this 392, here this is 280, so somewhere here it is 300 around, here 170. So here you can say that this one is the rich mix and this one is the lean mix. जिसमें सीमेंट प्रोपोर्शन कम है वो lean mix है, जिसमें सीमेंट प्रोपोर्शन ज़्यादा है वो rich mix है. So you can see this here, this range of size of aggregate, beyond which in the rich mix there is a decrease in compressive strength. In each जितना ज़्यादा rich mix है उतना ज़्यादा उसका strength down हो रहा है. So here in all these three mixes there is a decrease in compressive strength, and while in case of this lean mix there is a continuous increase in the compressive strength. And that's why it is said that in lean mix you can go for the bigger size aggregate but not in rich mix. Similarly here for different water cement ratio you can say it is 0.4, 0.55, 0.7. There is a maximum impact on low water cement ratio. There is a continuous decrease as the size is increasing. So it is affecting more to the water cement ratio which is lower as compared to this higher water cement ratio. So here in higher water cement ratio there is a reduction in strength is there, but it's very less as compared to low water cement ratio. Now this is the other aspect that you should know, which is called as bond strength, because this proper bond strength is very essential for attaining good strength of concrete. So there are two types of bond strength between paste and steel reinforcement. So this is very important whenever it is we are going for the RCC structure. And the second bond strength is paste and aggregate. If proper bond is developed, then it may result in good strength of concrete. So first we'll discuss about this bond strength between paste and steel reinforcement. So this bond strength between paste and steel reinforcement are very important. Okay, and the in our RCC design fundamental assumption वही होता है कि there is a perfect bond exists between concrete and steel reinforcement. Okay, so this bond strength arises primarily from the friction. आता कहाँ से bond strength? Friction and adhesion between concrete and steel. Friction and adhesion, these are the two responsible factors for the bond strength. And the roughness of the steel surface is also one of the factors affecting the bond strength. So the bond strength of concrete is a function of compressive strength and is approximately proportional to compressive strength up to 20 megapascal. 20 MPa तक तो you can say that it's a function of compressive strength. Okay, so this is directly proportional, you can say up to 20 MPa. जितना अच्छा bond रहेगा उतना अच्छा compressive strength आएगा. But for higher strength, increase in bond strength become progressive smaller. जैसे जैसे आपका strength of concrete is increasing, this bond strength becomes progressively smaller. Also, it depends upon your gel. So cement which consists of higher percentage of C2S, if जिसमें C2S ज़्यादा है, it will give high specific surface of gel, and it will give higher bond strength. So if your cement it contains more proportion of C2S, it may give good bond strength with the cement gel. But on the other hand, concrete which contains more proportion of C3S and concrete which is cured at higher temperature, then it will result in smaller specific surface of gel. यहाँ पे specific surface of gel कम है, तो it will give you lower strength. So you can say अगर bond strength कम है तो definitely compressive strength will also become low. Also, it is observed that high pressure steam cured concrete, अगर high pressure steam curing करते हैं हम concrete, and which produce the gel whose specific surface is about 120 of the specific surface of the gel produced by the normal curing. So यहाँ पे high pressure steam cure concrete में भी आपका gel formation है वो कम होता है as compared to normal curing, and that is why this bond strength of high pressure steam cured concrete is correspondingly lower. So these are some of the observations that suggest that if proper bonding it is not available between the cement paste and reinforcements, then they will be responsible for lower strength of concrete, and it will affect more to this concrete which are having a higher strength. उसकी increase in bond strength become progressively lower. Okay. And this is the second bond which is also responsible, that is aggregate cement bond. Okay, so similarly when cement has the bond with reinforcement, similarly proper bonding has to be occurred between aggregate also. So basically it is the chain in which aggregates are bonded together by cement paste. So this bonding is very essential, and basically you can say that the strength of concrete as a whole is dependent upon the bond strength of hydrated hardened cement paste. So basically it is the hardened cement paste जो properly hydrate हो चुका है, means basically it's a gel formation जो hard हो चुका है, that is actually responsible for the bond strength, and that is called as the hydrated hardened cement paste. And this strength of hydrated hardened cement paste, it basically depends on water cement ratio. As you know that cement paste का जो भी formation है depends upon the water cement ratio, and which actually determine the quality, continuity, density, porosity, all other different properties or the products of hydration, and in particular CSH gel. So ultimately this CSH gel, that is actually the hydrated product, that is actually responsible for the strength aspect and also responsible for the bonding. So proper bonding, proper CSH gel formation is very important. So you can say that stronger the gel bond, stronger is the concrete. So gel अगर proper होगा, proper bonding होगा, then it may result in stronger concrete. So aggregates generally being, ऐसे देखा जाए तो strength wise if you consider कि भाई aggregates they are generally being stronger than the paste, its strength is not of that much consequence in the normal strength concrete. Okay, it's only that gel which is very important, though these aggregates are having more strength as compared to this bond strength, not bond strength, it's a gel bond. The strength of the concrete is limited by the strength of paste only. Okay, so though this aggregate that not much important, that strength उसकी कितनी strength है इतनी important नहीं, but the bond is very important. Okay, and only it is said that the strength of concrete is limited by the strength of paste, and it will hold good when it consider that concrete as a two-phase material. We are considered that it is a two-phase material, but the structure of the concrete suggests that there is a third phase. It comes into consideration. What is that third phase? That is the interface between paste and aggregate, because that is considered as a transition zone जहाँ पे weaker section आ जाता है. So that is the weaker section. So ultimate analysis it is said that the integrity of the transition zone that influence the strength of concrete. अगर आपने transition zone का जो है वो integrity maintain कर लिया, so that may result in proper bonding. So basically this integrity of the transition zone that actually influence the strength of concrete. So apart from this bond, aggregate characteristics other than this bond strength, such as size, shape, surface texture, and grading, they are also known to have some impact on the strength of concrete. Okay, so in this particular part we have learned all the different factors which are affecting strength of concrete, and how this water cement ratio, gel formation, time aspect, temperature aspect, that are all very important whenever we are considering the strength of concrete. So thank you very much.